So we have looked at dealing with how we add and subtract positive and negative numbers, which are called our integers. And so now we're going to look at how do we multiply those, and this is 1 6. And so quick little review is what is an integer. And we have our definition here. Whatever I write down, I highly suggest you write down on your paper. But an integer consists of accounting numbers, their opposites, and 0. So I love this first example. Okay, it talks about we're playing a board game and the unlucky Lawrence had to move back 2 spaces, but he did that 4 turns in a row. What integer represents his change in position? Well, since he's going backwards 2, and I love the number line, how it represents, 0 is our starting position, and we're going backwards 2, that's for the first turn, but then we do that 4 times. And where do we land? We land 8 spaces backwards, which we can represent with a -8. And so this shows us a real life example that shows us that a positive number times a negative number is going to give you a negative answer. And we have that rule down here in the box that I just boxed in. You could turn your book to page 40 and box it in on your page as well. We're going to get ready to look at the try it, and you can look in your book for that try it as well. It is on page 40. So now let's look at the try it. It says a race car takes 6 points from each player each time the player hits a cone. So what integer would represent the change in total points if the player hits 10 cones? Well, if they're taking those points away, we know that it's going to be a takeaway 6 points for each cone. And if we hit 10 cones, we just learned a positive times a negative is going to be a negative answer, and 10 times 6 is 60. So the change in the total points is a takeaway 60 points. I want to show you another way that I always like to look at these problems and how we can represent it. I went too many slides, I apologize. So now that we know that which I'm assuming we all know, back to our multiplication facts from elementary, 2 times 3 is 6. So a positive times a positive is a positive answer. And we just learned what happens if we have a negative times a positive, and we learned we get a negative answer. So I'm going to fill in my table here, because what you're going to determine and figure out is what a negative times a negative actually gets you. So let's start with a negative times our positive. A -3, I'm right here. A -3 times a +3 is a -9. And a -3 times a +2 is a -6. And a -3 times a +1 is a -3. And a -3 times a 0 is 0. So let's look and see what's happening. My -3 is staying constant, meaning the same. I'm multiplying every single time. And what is happening to my values that I'm multiplying by? I go from 3 to 2 to 1 to 0. What comes next? A -1, and then a -2, and then a -3. And so let's take a look at how our answers are changing. I'm going from -9 to a -6. I'm actually going up 3. I'm going from a -6 to a -3. I'm increasing by 3 more. -3 to 0 is increasing 3 more. And so if I increase 3 more, a negative times a negative is actually going to give you a positive. And a -3 times a -2 would give me a positive 6. And a negative 3 times a negative 3 would give me a positive 9. So if we wrote this all out, and I'm going to summarize it here for you. We're going to go to slide 3. If the signs of the factors are the same, so 2 and 5, they're both positive. 2 times 5 is 10. And what about a positive 5 times a positive 2? That is also 10. Positive 10. We know the order we multiply doesn't matter. Commutative property of multiplication. Talk to me about what we just learned with a negative times a negative. So my signs are the same. I have a negative and a negative, and we just learned that our value will be positive. And again, the order we multiply doesn't matter because of the commutative property of multiplication. So a negative 4 and a negative 3 is going to be a positive. So if the signs are the same, we are going to have a positive answer. And we also saw or looked at that if the signs are different, so if I have a negative 4 times a positive 5, I actually get a negative 20. The 4 was negative, the 5 was positive. We had a negative and a positive, different signs, negative answer. 5 times negative 4 is a negative 20 as well. Again, commutative property. Now we have a positive 4, but the 5 is negative. So we still have different signs, a positive and a negative, and that gives us a negative 20. And again, back to the commutative property, a negative 5 times a positive 4 is a negative 20. So if my signs are different, what do we know? We're going to have a negative answer. I hope that we can look at our problems and determine if they should be positive or negative before we even do our multiplication. We're going to look at the last try it on page 41 in your book. There are problems. So I am on page 41. And before we even get started here, I just want to talk about, is A's answer going to be positive or negative? Same signs, a negative and a negative. So same signs means my answer will be positive. Good. Now you just multiply. 7 times 2, which is a positive 14. Let's talk about B. I have a positive and I have a negative. And so we know opposite signs. One's positive, one's negative. So we're going to have a negative answer. And we know that before we even do the math. And if we do 7 times 13, we get 91. So my answer here is negative 91. How about you try C and D on your own? We can discuss in class. That's it. You know how to multiply positive and negative numbers. Integers, I should say.